This shows that there are actually two different types of reactions, and we've named them an E1 and an E2 reaction. So first, let's discuss the E1 reaction and which of these two examples we've talked about is an E1 reaction. The E1 reaction follows through this mechanism. It is akin to the SN1 reaction. Generally, just like with SN1, first our leaving group is going to leave. In this example, it would be bromine, forming a carbocation. Remember, again, this is the same first step as an SN1 reaction. Then secondly, the proton on an adjacent carbon is removed by a base to give your alkene, or double bond. This is called an E1 mechanism because just like our SN1 mechanism, it is unimolecular. One molecule at a time for the slow step, right? The slow step just involves the leaving of our leaving group and the formation of the carbocation. The second step is a completely removed from our formation of carbocation. The rate determining step, the slow step, is the loss of the leaving group, just like in our SN1, and that formation of the carbocation. So this explains why the reaction is substrate dependent, because the slow step only involves the substrate. The rate is proportional to carbocation stability, and the loss of the leaving group is also the first step in an SN1. So that's why SN1 byproducts are observed with an E1 elimination. So again, E1 is first order. It was the reaction we talked about that is first order. It is the reaction that uses a weak base, and it only involves the substrate. So doubling the concentration of the substrate will double the reaction. However, doubling the amount of water here has no effect on the reaction. Because formation of a carbocation is key to the E1 elimination reaction, just like SN1, the tertiary substitutes are going to react faster than the secondary or the primary substituted reactants. So for example, the rate of reaction with a tertiary bromide carbocation versus a secondary versus a primary, shown here, would be as thus, with the tertiary reacting fastest and the primary reacting slowest or not even at all for this type of elimination reaction. And again, that is because of the key step of the carbocation formation. Don't forget from our lectures on SN1 that the reason that tertiary is better for a carbocation is the stability that is provided from those extra groups on the surrounding the ion.